Right, these questions are amplifier questions, and this is the characteristic graph of an amplifier. What this graph tells us is that if we look on it, we can choose any points on the lines and say, let's look at this point here. We can say the input was, this is input, was 10 millivolts, and the output, according to this, was minus 3 volts. So it turned 10 millivolts into minus 3 volts. It's an amplifier. It made it bigger. 10 millivolts is 0.01 volts, and it turned it into minus 3 volts. So from a small voltage to a large voltage. This is how an amplifier works. They want to know the voltage gain in this linear region, so along here. So you can choose any points along here, we'll get the same gain. In this case it's 0.01 volts, because I chose this point here. Turns into minus 3 volts. So to work out the gain, it's that one divided by that one, which is 300. Now, if we put the negative in there, it would be negative 300. But in terms of the voltage gain, we just want to know how much bigger it got. So we only have to worry about the number. 300. If they'd asked for it, in this case, it's an inverting. They didn't ask for it in this case, but this is an inverting because it turns a positive number, 10, into a negative number, minus 3. Right, here's the same characteristic graph in question 7. Here's the input signal to an amplifier. Where to draw the output signal, what it looks like. So if you look at the characteristic graph, anything up to 30 millivolts gets magnified 300 times. That's what we worked out before. Anything over that, so 30 millivolts turns into minus 9, so 9, and 40 millivolts, here it is here, also turns into minus 9, and 50 millivolts also turns into minus 9. So anything over 30, plus or minus 30, is clipped. So this input signal goes to 10, 20, 30 millivolts, it goes to 40 and 50, it gets higher than that. So anything over that's going to be clipped. So we know that overall this is going to be clipped like this. We also know a positive 30 millivolts is turned into a minus 9. So it's an inverted graph and it's clipped. So if we were to draw that down here, there's 3 marks. The 3 marks are for 1, having it inverted, 2, clipping, if it has to have that, and 3 is for the scale. I know that I go up to, the biggest I can get is 9, on positive 9 or minus 9, so what I'm going to do is, I'm going to say 1, 2, 3, that's my minus 9 volts, the third one down, and 1, 2, 3, that's my positive 9 volts there. Starts going up, but because positive 10 millivolts, positive 20, positive 30 gets turned into the minuses from this graph here. Positive 10 turned to minus 3, positive 20 turned to minus 6, positive 30 turned to minus 9. It's inverted, so it's upside down. Okay, it would keep going along here, but it's clipped, so we've got to put it flat. And flat. There we go. So if it wasn't clipped, it would look like this, but it is clipped, so that's not in it. Oh, and our scale we've done, so we're all done.